Till now, we have seen a deletion node at the beginning, at the end. Now we are going to see the deleting a node at the intermediate position. What do you mean by the intermediate position means? Now, if I want to delete an element at the second position or the third position, this is a specified position. So, if you want to delete at this specified position, we need to say that position and we need to indicate the value here. For this purpose, again, I require the two pointers. One is a temp pointer, again the previous pointer. Like how we have taken the two pointers in the deleting a node at the end, in the same way we require these two pointers also to delete an element at the specified position also. Now see, initially the same thing. Whatever we have implemented at the end, the same thing is going to happen here also. That is, temp pointer will be same as that of the start pointer. Temp equal to start, which means that whatever the value is there here is going to be placed here also. After that one, initially previous value will be null. Why? Because why I require the two pointers again? See, I want to place I want to delete this particular third element. So what I have to do? I need to start traversing from the beginning to till this point. Why? In order to delete this one, this pointer should point to the fourth element. But where is this particular address? It is there in the next one. So this one should be marked as the temp and this one should be marked as the previous one. Then only it is possible. Yes or no? See, I want to delete this one. In order to delete this one, I need to change the previous address. This should point to the next element of this one. Where is this address? It is there in the next element. So we have to replace this address with the next one address. This is our task. For that purpose, we require the temp pointer and the previous pointer, like how we have taken in the deletion at the end. The same thing, temp will be same as that of the start value and the previous value will be null. After that, what I have to do? I need to start traversing till that position. Now, if you observe this one, this is the third position, right? First one, second one and third one. So, I need to reach up to 1, 2. After reaching to the 2, I should change this address. I should change this address. And how I have to rotate this one means, we will start from the I equal to 1 and I should move till the less than that position. If I want the third position to be deleted means, I should be at the second position. So, I less than the position and in between that, the temp value should not be null. I plus plus. Now see, previous equal to temp. Now we have to change this previous value with the temp value. What is the temp value here? 100. Now the previous value should be changed as that of the 100. Like this. After that, temp equal to temp next. If you observe this one, previous is now pointing to this one and the temp should point to this one. Where is the temp address? 100. Initially temp value is 100. Yes or no? Now, when you write temp equal to temp next, what is the 100 next value here? 200. So, replace that 100 with the 200. This is what here we are doing. So, after first loop, what happens here? This will be treated as the previous one and this will be treated as a temp. Now, again, is that the correct one? No, still I plus plus. Now, the I value became 2. 2 less than 3? Yes, the condition satisfied. So, again I will get into the loop. Now, again previous equal to temp. Initially previous value is 100. Now, if you are right, previous equal to temp, what will happen? This will be replaced with the 200. What is the 200? Temp value is 200. So, I am going to replace that 100 with the 200. Yeah. Done. After this one, I need to again change the temp value. Temp must be equal to the temp next. See, this is pointing to the previous one. Now, the temp should be here. For that purpose, we need to write temp equal to temp next. 200 next is 300. So, the now temp value is changed as a 300. Yes, I plus plus. Now, the I value became 3. 3 less than 3? No, the condition is not satisfied. I will come out. Before you come out from this loop, you check the values. What is the temp value here? The temp is pointing to this one. And the previous one is pointing to this one. Done. Our task is completed. Now what I have to do? I need to just change previous next address with the temp next address. This previous next address must be replaced with the temp address. How can I write the code here? Temp next value is sent to the previous next. See, this is a temp and the temp next value is 400. That one is replaced into the previous next one. Yeah. See, here in this example, we are deleting the second node. Just we will see the algorithm. Till now, we have seen the logic. But how the algorithm should be means, here you need to say that if the list is empty, then it should display that the list is empty. Or else, if the list is not empty means, we have to follow that logic. What is that logic? I need to rotate from the first position till less than that position, and here we require the 2 pointers, that is a temp pointer and as well as a previous pointer. Initially the temp value will be same as that of the start pointer and the previous pointer will be equal to null. But after getting into the loop, we are sending every temp to the previous one and we are changing the temp to the temp next value. That's it. If temp equal to null in between, then it is treated as the position is out of the range. If your list is only of the 10 elements, but you want to get in between the 12 or 13, then what happens? It should say that position is out of the range. Or else, directly we are going to change the temp next address with the previous next and free of the temp. We are deallocating the memory. Now just we will see the program. Initial temp value will be the start and the previous value will be null. If the start equal to null, which means that here there is no linked list at all, there is nothing to delete. So we are going to say that the list is empty. Return statement will help you to come out of the function. The next one is if the position equal to 1, if you want to delete the first element, already we have discussed that, we can directly call the delete from the begin function and return statement will help you to come out of the function. Or else, I need to rotate, I need to move till that less than position, previous equal to temp and the temp equal to temp next. With this one, I will be at the specified position and at the previous pointer, just by writing previous equal to, if the temp equal to null means we can say that position is out of the range. Or else, temp next value will be sent to the previous next and then deallocate the memory by using the keyword free of temp. That's it. Now we are going to see the same coding with the adding to the previous one. Till now we have seen the coding at the deletion at the beginning and deletion at the end. Now we are going to see the extension that deleting at the specified position.
Now again we need to perform the deletion at the certain position. We require that, right? Similar to what we have performed now. Yes, deletion at the begin completed, deletion at the end completed. Now we are going to start the function void deletion at the certain position. So let me write deletion at position. For this one, we require one parameter, right? I just need to ask for the parameter. So we are going to go with the option POS, one argument specifier, that is POS. Done. Now, for this one also, I required 2 extra pointers, that is a struct to node pointer, temp, which will be same as that of the head. And another pointer we required here is the previous pointer. Why? Because I need to change the address. So again, previous equal to, initially we can mark that one as a null. Done. After this one, what I have to do? If head is not equals to null. If head equals to null means we are going to display that the list is empty. Head equal to null. We are going to display list is empty. The list is empty slash it, and return statement will help you to move out. And after that, if the head is not equals to null, I'll move to the else part. In this else part, we are going to write our main logic. Done, right? Done. Now see, what should happen here in this else part? Already we have taken the temp value and previous value. I need to rotate my loop till I reach that position, right? For that purpose, first we are going to start for I equals to 1 and I less than position. I less than position. And after that, even in the middle, it should not be, the temp value must not be equals to null. I plus plus. Done. So in this loop, what I have to do, I should just keep on moving forward by changing the previous equal to temp, like how we have done for the deletion at the end. The same thing we are going to do. And temp equal to temp means I should not do anything. I should just mark the previous one and I should mark the next one. Temp equal to temp and temp reaching to the next. Yes. After reaching to this particular point, what I have to check again, if meanwhile, again, if temp became null, it should see that the position is out of the range. It should display that the position is the out of the range. Why? Because it should be in the center only. Within our range only it should be. But if the temp value equal to null means our position is somewhere else. So we are going to print position is out of range. Done. Or else, what I have to do? I should change the previous one address, right? That is previous address equal to, I need to delete the temp one. So previous next address must be replaced with the temp next address. Why? Because the temp one I have to delete. So again here I'm going to mention free of temp. This is what we have discussed till now in our algorithm. That's it. After this one, we are going to say that printf value is deleted successfully. Node is deleted at position %d /n. Let me even write that position value also by adding POS. Done. Save your code. Yes. Now we need to make the choice in order to call that deletion at the position also. So add that one. Seventh choice to delete. At position is a /n and after that close this. And even in our case also we are going to add, that is a seventh case. Till now we have completed all the 6 cases. Now we are going to enter our 7th case, that is a deletion at the position. So deletion. No, before that first it should ask me to enter the position, right? So write the statement, enter which position you want to delete. Enter the deletion position /n and scanf statement to read that position. Scanf %d comma ampersand of position. If you observe this variable, already we have declared this variable for the insertion at the certain position. So the same variable we are going to use it here also. After this one, I'm directly going to call deletion at the position and we are going to pass this POS as a parameter. So pass it as a parameter. After this one, call the break statement. Done. Now save your code. Compile the code. Yes, 2 errors. Yes. Let me declare it here int I equal to 1. Again, save your code. Compile the code. Again, one more error. Yeah, scanf spelling. Save the code. Compile the code. Done. Now, enter your choice. Yeah, again, I'll go with the option insert at the begin, 23. And again, I'll go with the insertion at the end. I'll go with the value 43. Again, insert at the begin function with the value 90. Let me go with the option. Enter your choice. Again, let me go with option 1, 98. Now go with option display. Yes, if you observe here 98, 90, 23, 43. Now I want to delete the position which starts with the third position. Let me choose option 7 to delete at the certain position, and I want to delete the third element position. Yes, node is delete at the third position. Let me display that one again. Observe here 98, 90, 23, 43. These are our values. Right now, let me go with this part. Third element got deleted 98, 90, 43. The previous third element was deleted successfully. Yes. With this one, we have completed all the 6 functions, that is insert at the begin, insertion at the end, insertion at the position, deletion at the begin, deletion at the end, and deletion at the position. All the 6 functions are completed successfully. And the one more function we have utilized is that is a display function. If you observe the display function, just we are keep on traversing by using the while loop. Nothing is there in that display function. What we have done, if it is not equals to null, I'm going to print my data and I'm just moving forward by writing the statement temp equal to temp next. That's it. This is about the display functions. With this one, we have successfully completed our single linked list program with all the 6 functions.